What if you threw a baseball up in the air and it never stopped? And then not only did it defy gravity, it started racing away faster and faster with nothing propelling it. That's exactly how astronomers felt in 1998, except instead of a ball, they found the entire universe was racing apart faster and faster by the instant. So why would the universe do that? Our best theory is that there's something invisible all around you. And even though you've never seen it, it makes up 70% of the universe. It's called dark energy. So 20 years ago, by looking at supernovae, astronomers noticed that the universe wasn't just expanding outward, it was actually accelerating faster and faster outward. Not even the explosion of the Big Bang could have set this in motion. And they began to think maybe space itself is expanding. But saying space just is special and expands is kind of random. It's like having magnets and seeing them attract and just say, okay, magnets attract, and not worrying about electromagnetism or the fields involved. Now, remember, in Einstein's view, space-time is basically this mesh that just sits there unless energy or matter bends it. And you might have seen videos or images of the bending of that space-time mesh that causes things to attract. But maybe there's a special kind of substance, something invisible and undetectable, that pushes the space-time mesh apart. Imagine that space is full of bubbles that repel each other. And whenever there's enough space for a new bubble to form, it does. And that bubble repels all the other bubbles. And then bubbles keep popping into existence, pushing each other apart and pushing space with it. So space and time probably isn't made of bubbles, but on really small scales, you actually do have particles popping in and out of existence. They're called virtual particles, and they live for a very short time before they annihilate each other. So maybe the energy of these particles is what's causing the universe to expand. But if you calculate the amount of pushing from all the virtual particles that exist in the standard model of particle physics, you get too much pushing. You actually get a trillion times too much pushing. So our current quantum theories of particle physics can't explain observations of dark energy. And some people think we just need to add something onto those quantum theories, something like supersymmetry. But other people think that we actually need to change our theories of gravity, change general relativity, so say space itself expands without worrying about these particles. Either way, dark energy is even hard to imagine. Even in our shows here at NOVA, we show some beautiful things, but they're not what dark energy would look like. If you made dark energy, say, green so you could see it, it would actually look like this. It has the same density everywhere. And if it started to expand, it would actually do this. You see it expanding? Dark energy doesn't even get diluted because it's embedded in space. As space expands, you get more space, but you get more dark energy with it, and it looks the same. For now, all we know is that the bigger the universe gets, the faster it flies apart. And one day, the distance between our Milky Way and the neighboring galaxies will be growing faster than the speed of light. When that happens, even our best telescopes won't be able to see those galaxies. So I say, let's get to know our neighbors while we still can. For much more, check out Nova Wonders, What's the Universe Made Of? And if you want to see more What the Physics, please subscribe. I can't believe I caught it and then dropped it.